Just getting things started. Looks like a success. Get into the game. Or the dev environment, I guess you can call it. Switch the screen. Do a quick check. Looks like I'm fine. All right, so we are now going to do some tweaks. As I said on my last last stream, we started a listen. We're going to actually make a listen TCP and a listen UDP function. Which shouldn't be that hard to add. We're going to have connect with the two different versions too. The Copilot is super fast when it actually does its job right. Okay. So we'll let it recompile, and while it recompiles, login uses UDP here. We can switch this to TCP. And theoretically, I'll be able to start the login client, CFG, client, CFG. We change this over to 8191, do so on 127001. Okay, what did I mess up? Oh, I forgot this. And give me TCP. There we go. Why is listen UDP? Oh. No. Oh, this is actually an error about connect. UDP and TCP is types. I think these are just lingering errors from my previous compile. There we go. All right, so if we run login, we get the network connected, but we aren't getting the send raw successful. But that's okay. We're just going to run the client and see if that sends a proper message over. All right, so it says socket connection error. 8191, connection refused. I don't think it's binding properly for some reason. So it's supposed to be calling connect TCP. Which, once connect TCP is done, and same with listen to TCP. Accept incoming connections and read data from clients. I can just apply this. No. Yeah. Let's add a flag. What did I mess up here? I have a conditional. But then this code isn't considered. Why? Did I mess up one of my brackets? Oh, I must have removed the semicolon on the end somehow. It's because this is the UDP style and this is the TCP style. Let's see if they can fix my close logic. I think the other thing is this could actually be a UDP connection. I didn't realize till now that they closed the handle. that could actually cause some weird side effects. All right. Network connected, question mark. Let's flip it back to UDP. Bind 98. Okay. There's the UDP message. We're getting connection refused. Okay. So now let's swap it to TCP again. We're getting connection refused. Why? Is it because of the net connect? I don't think it runs on a limited lifetime or anything. Oh, look at that. We're getting a bind error. It's like the port is lingering. What does 98 mean for error number? Well, that's an easy one. Address is already in use. When this gets aborted, well, let's just build for now. See, this is trying to connect to 8191. We're trying to put a listener on 8191. I've been trying to use both TCP and UDP, but it doesn't seem to work. Some sort of lingering socket connection too. But yeah, we're still getting the connection refused error. I think it's implying it's actually a TCP connection. Man, the scaffolding to this. It's implying it's TCP. So here's the next question. I'm actually not closing. Yeah. That looks good. I don't think I actually need pull messages to be declared, but we'll see. Oh, what's the return type on these? I think they're both void. Why don't these match? Is it I need to include something? Yeah. Okay. So now we handle multiple messaging. One thing I don't like is if it's TCP, do this handling and then just return. And the same with this. Yeah. Oh, I need this to be TCP. That's probably part of the issue. Not that it fixes all issues, but... When you just give me... Hmm. I don't know if I like that option, but sure. So we're going to be setting a sock option. Didn't actually know where to put this. No, I don't like that. So listen TCP. Ultimately, I think I put it there. And also uncomment this. Hmm. This isn't related to my problem, but it might help. Why do you take so long to save sometimes? It's super annoying. Why is close result error a failure? Close result is result of close. Close is properly a... What do you mean? Oh. Okay. So one issue... This option needs to be set before bind. Can you just let me copy this? Damn. Copy, click, paste. All right, so always set reuse address before bind. Make sure none of the processes are using the goat. Possible I have a pseudo problem. How do I install NC? It's like Network Essentials or some shit like that, right? Okay, well, at least we have a easy environment to test this against, but I'm having an issue with my listener, 8191. Whenever I try to connect with TCP, it's just failing. It might be a lifetime problem. Maybe I can spin up login in a debugger with a breakpoint on update, because this gets called all the time. And while we're in this space, can we see NetListener? So we can see that NetListener is indeed in memory. So it hasn't deallocated. There is this infinite loop going on the connection. And it's possible yeah, we're not even getting a handle client call. Let's make sure this is getting called properly. Cool. We're getting pull messages. It gets a handle client receive here. Goes back to pull messages, does a client received. But see, it stops. Is it just returning? Is the thread dying? Obviously there's a close. It disconnects the server client connection here. But that shouldn't cause the listener to close, just the client FD. Okay, so we have this infinite loop. We have the connection coming in. We get the message. Coming again. It returns from pull messaging the moment a connection occurs. Pull message is supposed to be a loop. But isn't pull messages a thread here that's just looping forever? Why is it? Could be the handle client function is closing. Okay, so we're taking messages and this is in a thread. So this should be getting called over and over. I don't know why that thread is failing. Okay, so we have a new client and we're receiving messages. Do we ever get close? Did polling get set to false somewhere? This thread should be infinite, but it's not. Hell, we're not even closing it properly when we call close. This is the wrong one. Can I just do something like this? I don't think any of this fixes our underlying problem, but Why does it take forever? Jeez. Are we thread locking? That's possible. We pause and look at all the living threads. Whole message is still on a thread. Is this a blocking call? See, that just returned. Got a second one coming in. Okay. Okay. When in non-blocking mode, if there are no pending messages, accept will return a -1 with an error of these two types. So what we need to do is on the exception, okay. I don't know if this fixes my root cause issue, but it does fix a logical one, which is I want this to just pull, try to accept, pull, try to accept, pull, try to accept. That's what I wanted. We're still getting connection refused. And I'm pretty sure the port is not open. But we're getting farther along. Any other theories on why the net listener is not staying open? We know that this is staying in memory. Honestly, what I could do is, like, right now, we're just chilling. If I go to nel message and add a breakpoint right here, it keeps hitting it. You see that? Boom, boom, boom. So we're pulling on this socket. If we break, we should see a thread here, currently on a sleep, attempting to get this. Why not? So they create a proto subdirectory with gRPC pb.h as header files based on if it's a Bazel build or not. Then you have the port listener, a service implementation here, which ultimately runs a server, adds a listening port for the builder, registers the service, runs it, waits on the shutdown. So this is a blocking thread. And this is ultimately what the main does on here. Then the client has a lot of using clauses. I don't know if I like that. So the greeter client will say hello as one of its methods, starts a request, sets some values, does a reply, sends a message across what's called the stub, status returns an OK, and return the message, otherwise do an RPC failure. And this is by creating a channel. This code is pretty damn straightforward. There's a part of me that wants to just go ahead and implement gRPC. We have async though. This is probably gonna be more complicated. So we have a message of say hello. Request that upon completion of the RPC reply be updated with the font status with the indication of whether the operation was successful. So there's an RPC finish indicator. That's a little weird. And ultimately it's doing a block check here. Once it equals there's advantages to this style though. Because now you can just have a simple request reply methodology like this, where this is a blocking call. But here's another model. Okay. Yeah, the bidirectional streaming RPC is so clean. So you can design a RPC, you can implement the service, set up a unary RPC server. We'll not discuss how to create a channel and stub. If each RPC, besides a client, a request and a response, the client needs callback. Yeah, there's an argument. There's a lot of scaffolding that I'd have to relearn for C++ if I wanted to implement gRPC. But if I did go this route, I would have a proto file that agnostically, designs the contract. It'd be easier to write pieces of the code in different languages where needed, which could speed up development time. Because there is a lot of this that doesn't need to be in C++, to be honest. Not sure though I want to necessarily hit it up. But It's an option. If I start abstracting out a lot of the methods, I still have to use like serial in and do all that weird shit. My only complaint with Protobuff is it's a lot of scaffolding to incorporate. Let's ask GPT what's its opinion on it. If I were to introduce to the Ryzom core infrastructure my new own unique network service that handles callback, tunes and binds it to the existing code. Would this have any advantages and be considered a well, and what is the development cost from 1 to 5, 5 being? So contracted APIs via Proto with versioning and code gen. Yeah, I like that. Bidirectional streaming for logs, metrics, and admin taps, or for patch delivery. First class deadlines, retry, status codes, and back off. Built-in TLS, auth interceptors, and service health checks. Easy polyglot microservices. Cleaner observability with gRPC and set interceptors with OpenTelemetry. Yep. gRPC is HTTP2 over TCP, where HTTP3 exists, but still head of line at stream level. Latency, packet cadence, worse than your current UDP/reliability layer. So it would be laggier, but I think it'd be worth it, at least for like non-mission critical stuff. Payload framing and proto jitter. Yeah. Threading and event loop integration can fight your reactor. So with auth, account, entitlements, shard directory, inventory, mail, auctions, leaderboards, admin, GM tools, metric, asset management, patch record. Keep the existing stack for movement, combat, and state replication. One of my endgame goals is to move away from naming service and other orchestration tooling like Patchman inside Ryzom Core. Either making a single binary that has no orchestration for local testing, or deploying to a Kubernetes like environment and have it do ingress scaling management. This lessens the amount of code needed and simplifies the stack. What would you rate the doing 1, 2? Okay. What if I remove the UDP binding altogether when I move to Kubernetes and make it so for critical game logic, it uses fast TCP? Hmm. See what its take on that is. I know it's very agreeable to anything you say, but I want to see what it considers. Yeah. I know it's a lot of work, but I kind of want to go this route. Hopefully it understands that question and does a decent answer, because this is a big one. Yeah, the breaking change checks is so nice. Versioning discipline becomes manual. You truly run multiple codecs now. You need to do custom packing or zero allocation hot paths. Generate code and use it as your domain DTO. Mature tooling, breaking change guards, field reserves, one of evolution, wide language support, code gen, interceptions, reflection, works with gRPC and non-gRPC. The ergonomics of Protobuff aren't perfect for C++. Some allocations map one of sharp edges, couples domain names to wire names unless you wrap. Most teams, you want the speed of development and fewer moving parts. Make domain entities separate. Treat request response contracts as wire models defined in Proto. Map entity/contract only at boundaries that cross process or trust zones. For quick without gRPC, still use Protobuff payloads to transport share the same contracts. You can still use JSON/Shibor/Meshapack or custom binary. Simpler debugging if you don't use Protobuff for tighter binary format. You have to rebuild schema rules, versioning, and tooling, usually not worth it. Okay. I was trying to make it so that I was leaning it towards Protobuff. And this all makes sense. I know I was writing this nil message that was like a raw TCP, and I have some weird minor lingering issues, but even like this scaffolding that I just wrote up, which is like 300 lines, this is too low level, and I don't think I need to do any of this, because I could easily just take in a gRPC type and also implement a quick type and just make these primitives that both use a Protobuff marshaller, design all of my endpoints in Protobuff, and design it so that all the services start using Protobuff as an abstract class, and essentially start stripping out all the logic. Because if you think about it, I'm pretty close to taking everything out, at least on login, and abstracting it into different interfaces. We need to fix... They got this display NL crap. I don't really like it. I don't really like the command system. It's too layered. And I also don't like the like messaging, the network stack, these callback methods. Essentially, I'm removing NL from the whole thing, the NL networking framework, and attempting to, like, all these callback methods, these will become Protobuff subscriptions. So we'll probably have to design each of these as services and essentially have listeners and dispatchers that can request and reply across the entire stack. And then these callback methods, very likely I can just start putting this inside of the login service. And essentially login service is just a wrapper. And then this code will just become just like a stub. It'll just initialize starts a listener, and is done. And then we move on to front end. Front end has, see, a lot of this is just scaffolding. And it has a lot of weird, like, it has to initialize login server, which, by the way, is already super confusing. That front end has a class called cLogin server that then has all this scaffolding to ultimately trigger like a connection chain for identification and cookies and all that stuff. All this, I think, is too abstracted, especially because it's hard to find all the methods that front end is actively handling. Plus this in-wire style, these all can just be put into Protobuff. And if I ever need to restructure, when I recompile Protobuff, it'll cause failures for the consumer if they, change the contract. This has zero assurance of that. And I think, again, I could simplify a lot of this code. Obviously, front end is really kind of a proxy where it'll take a message from the client and ultimately dispatch it. And what probably would make sense is that there would be two network service instances inside of front end, and one of them would be a gRPC wrapper, and the other would be a quick wrapper. The gRPC wrapper would be the default for sending messages across various services, where the network or the quick wrapper would just be for like client communication. I don't think the latency is going to be that bad. Like, does gRPC really add a lot of latency to a older MMORPG? Like, if WoW was using gRPC across its entire stack, would it be noticeably more laggy compared to current? See, client server streaming is I know it's kind of saying this with the P95/99, but so to review, if a client is sending their intent to attack, use quick UDP. When front-end service receives the intent to attack, it gets relayed to ECS. When EGS but if we wanted to store an event must never be lost. Yeah. Okay, I like it. And it simplifies the whole stack. I mean, I am going to lose performance a little bit, but it's going to simplify everything, in my opinion. But it's a lot of rewrite. It's essentially writing a new infrastructure. Ugh, I don't know. It's there's a debate still in it. But anyways, I'm going to stop stream for now. I think there's a few people listening in, but ultimately I'm just doing research. And that research was obviously the entire infrastructure of Ryzom uses the Nell messaging system, and it was written in 2005, and it's amazing. Sure, it does its job. There's not necessarily anything inherently wrong with it. Minus that it does have some string encapsulation in the data send, but it's in UDP. So really the cost of it's pretty minor. And but I'm not sure I'm a huge fan of it. It's not very easy to follow. It's very whimsical. There is no contract between services. And even just the flexibility of Nell networking, it's very rigid on how you can architecture things. What I'm thinking of doing is designing a proto file with all the contracts. Should I split my proto files for RPC definitions and request reply payloads being split so that Quick only has to implement the proto files with payloads, and that's a good question. Anyways, so yeah, split them. I thought so. Yeah, so you just have really simple message structs like this, ordered, very basic Protobuff files, and then you'll have RPC integrations. And these RPC ones we'll probably use a lot, honestly. Like, I would argue 80 to 90% potentially of all of my networking calls could be considered RPC style. And the only parts that really need to be quick is like the mission critical data, like stateful data, attack, targeting, movement, stuff like that. And even when that data gets back, we send a real back feedback to all the different clients of any sort of updates. But the actual storage of it and processing of it internally that isn't on the hot wire would still just use gRPC. And in the long run, this means that, like, if Tempo comes back and he wants to do a web browser based MMO for this game, all he has to do is, well, he'd have to technically take the gRPC integrations and move them over to web transport. So there's a little bit of red tape for that, but it wouldn't be that hard. He'd have to replicate the entire RPC stack, essentially. Not end of the world, though. Okay. Well, I think on my next project, or my next stream, I'll sit down and I'll see if I can figure out integrating my network service to use the gRPC one and make it where on initialization, you can pass it either or. It'll either initialize a quick session or it'll initialize a gRPC session. And then I'll start defining all my proto files. I'll convert login to proto. And then I'll start moving all of the server services here. And I'll likely start moving this code out of a lot of these hard-coded things. Well, you know, I'll start moving them out of this and just put them into command as stubs. And ultimately, dumb this down. I mean, it's not a ton of code. That one has 4,000. Front end is 600. Sorry, not 4,000, 400. 600. Position, another 600. But a lot of this is scaffolding. Sorry, Milpus. I know, I'm talking technical junk. I'm essentially rewriting the whole networking stack for this MMO. I might regret it, but it'll make me feel better. And honestly, once I get the foundational stuff done and I can just vibe, a lot of times, honestly, once I get enough examples out, gRPC could likely auto-generate a lot of this. And because I'm abstracting things out, it's going to be even faster. And then I just have to audit the code. May have to go in and do some like tweaking on like guards and stuff. But the logic is going to be so much easier once I'm done to come in and just hack it up and like add new services. Because I'm going to be doing some major revamping. And when I do that, like even positioning right now is going to be like a lot of the instancing in this game, I believe, is only XY. There's no XYZ. I guess there is Z coordinates in here. They have vectors. Or at least the word vector. Well, the vector isn't necessarily 3 dimensions. It could just be 2. But I do see some Z variances of position. I'm struggling with my little little class. No, it's all good, dude. It's a big undertaking. And there probably may be advice to not do this, but I have no deadline. When I'm done, if I finish, I will have a full stack MMO rewritten in a way that is very easy because it's decoupled to implement your own variances, right? Like you could add in web transport or like, oh, I want to use NATs and like a message queue system. Or hell, I want to write Python to come in and communicate with the different services and inject my own logic. That would actually be very doable because Protobuff and gRPC supports Python. So actually, I gotta double check. Does gRPC have a Python integration? It does. It's right here. So like, you literally can spin up a gRPC IO package instance in Python, use my proto files that I'll have defined to generate your code here with the Protoc tool. And now you get the way to like integrate methods or even send out messages like this. And you can communicate now with the server. So that whole language agnosticness is going to be huge because some of this logic, I know I'm going to want to move it over to Go because I am insanely fast with Golang. And if I could lessen the burden of C++ code, especially like on non-critical path stuff, I could rapid fire improve it. So we're just adding a language agnostic layer to this. And the only thing that's going to have to require quick is C++ to C++, which means minus like if you're going to write a client in a lot of cases, you can just layer in. And honestly, you could just use web transport if that's the case. We're just learning some intro SQL stuff and GUI things. Big picture, I'm sure it's easy stuff, but it's a big difficulty spike. Yeah, SQL is one of those critical like first steps in most programming classes. The bright side about SQL is it's really not that hard at the end of the day. Like I always use the pants SQL reference. Like if you haven't used this site before, I highly recommend it. This literally was how I learned SQL. Like, and this was, it was posted in 2007, which means I don't know if I learned it then, but to me, this is like the Bible. Like this is really all you need to know about SQL. Because what it does, and I'll walk you through it real fast, Milfisto, fellas, yeah. This is how, in a command line, you start a connection to MySQL. And you may never do this because you'll just use a GUI client or something like that. But at the end of the day, most of the SQL system ends up being this simple, where it's like connect to a database, right? Find the host name, your username you're going to connect to, defaults to port 3306, blah, 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 whatever. That could just be your client, GUI. So once you're in the database, you get a little prompt like this. And one of the first things you're going to have to learn and know is what's called a database. And a database is kind of like a collection of Excel sheets. Is the classic thing. Like a collection of spreadsheets is what a database really is, the term. So you create a database with a name. You can list them all with show. You can switch your active database by using the use call. So use DB name. Then you can list all the tables, and a table is an Excel sheet. So now you show all the tables. Then you can describe the table, and by describing it, you get a list of every single column and table name, like every field and how they're defined. And then if you want to delete the database, you use drop. If you want to delete the table, you use drop. If you want to see all the data from a table, you just do select star from table name. Okay. And then if you want to see, all the columns on a table, you can just do show columns. And then if you want to filter the data coming in, you select star from the table, and then you add the where clause. You go where, and then you add a field name, which is your, their filter key, and then equals, and then whatever your filter string is. And then, a little bit more complicated is you select all from a table where the name is Bob, and so this is a, double filter where both have to be filtered. And then it adds in how you do ordering. So at the end, if you put order by, you can say sort this. You see what I mean? It's just step-by-step reference commands. And if your brain kind of associates all the queries to this web page, you'll just hop on this web page. It's a big page. It has a lot of stuff, but you can just search and just kind of find. And because of how it's ordered, you kind of just evolve more and more, right? Like select distinct for unique records, get the sum of a column, joining tables. It's a really big example, but joining is definitely an important thing to do. How to create a user, how to change a password. These kind of change over time, some of these password things, but, recover from root, setting a root password, to do updates, deletions, deleting columns, making a column bigger, which you rarely use. You shouldn't. Dumping all the databases for backup. Actually, there's just a bunch of indexing on the bottom. You can ignore all that. So like, it's not even the full page. Like, to me though, if you can do everything on this page, or at least are familiar with most of these commands, you're going to be pretty strong in your SQL knowledge. Like, this is a great foundational thing. That's ultimately all SQL is, though. There are some other concepts that doesn't go over. Like, I don't think it ever talked about transaction. It has set transaction. I've never really used this for the other stuff. This is kind of like his, like, this is his notes. And a lot of this junk, I never use any of his other things. I mean, this is kind of handy, like an HTML color chart, I guess. And like, how to erase a hard drive with a magnet. This one's not bad. This is a bunch of command line things in Linux. But I don't use this site for anything other than, like, I've literally associated in my brain the word PANTZ, pants, SQL. And that's all I search for, is I need the SQL pants. So, anyways, yeah, dude, good luck. It's fun. But transactions is where it gets really interesting, because what you can actually do in SQL, and this is really important to kind of understand, is imagine, let's even, one sec. Aren't you unlocking? Oh. Imagine, okay, so you're working and you're doing some sort of important financial, SQL thing, right? And someone just paid for a product. Okay. So we're going to say Bob paid for a product. Okay. So they paid $5 for, I don't know, glue. Okay. So in SQL, in order for this to happen, right? Just to do this simple action of, Bob paid $5 for a glue, right? This single word actually almost always is going to have a minimum of 2 transactions, right? Two updates in a database in order to have this, right? Because you're going to typically have, let's say, Bob's wallet, right? Loses $5. And the warehouse or the store loses 1 glue in stock, right? Like, that's usually the minimum that's going to happen, that, in order to satisfy Bob paying for glue, right? You'll have some sort of like inventory, and you'll have some sort of wallet to track the money that, Bob has. And it's important that both of these transactions work, right? Because if this update happens, but the store doesn't lose the glue in the stock, right? Like, let's say the transaction fails partially, Bob just loses money. And in the same respect, if the store doesn't lose the glue, you're going to have a desync where they'll show glue available when it really isn't, right? So it's important that both of these succeed, right? They're tied together. You need both of these to update. So we're just going to write pseudocode. Yeah, ignoring all that, because you can obviously complicate this. I'm just trying to keep this really simple. So you can see here, this is even auto, writing the SQL for me. But you can see here, update wallets, set the balance equal to the balance of, whatever the existing one is. Subtract the $5 where the user ID is Bob. Yeah, this totally works. And then same with updating the store inventory, set the stock to stock -1 where the item equals glue. Okay, really simple. What's the problem though? That there is no no guarantee that both will succeed, right? And if one fails, you have a bad state, right? So what's the solution? Transaction. Will it just write it for me? Let's see. GPT's fucking up again. Why did, I mean, it was doing so good earlier. There you go. So you can essentially do this. So if you do the word begin, you create a, I guess you can call it like a session, right? Imagine when the moment this word begin happens, you are starting, in fact, isn't this supposed to be transaction begin? I'm not fully confident. I don't usually write it manually. How did its transaction begin? Oh, begin is, but transaction isn't. It's start transaction. That's what I used to see. Anyways, we'll just do beginning and try to commit. Well, this isn't going to be that complicated. I just wanted to explain this. So the answer to this problem is what's called begin and commit. And this is a form of transaction. And transaction allows you to basically say, queue up these actions, right? And do essentially a session, but don't execute the commands until commit occurs. And once commit occurs, this whole transaction completes. And if either of them fail, right? So like, let's say stock had, not enough or something, the whole commit can be unrolled back. It's called a rollback. And by doing that, it'll undo both changes. So they're now bound together. You see what I mean? So super important. Because you can do things like, that kind of stuff. Typically, you don't write this all in SQL, but you could. You could write an entire script that does all of this and has all this logic, but that would be an immediate failure, right? Because like we first have this, right? But now we also need to do selects to verify that like the store inventory does have enough stock. Can you actually write this? Yeah, you can do it like this. This is actually valid. So now we have validation where if there's this edge case, if they don't have enough money, you can roll back. Or if they don't have enough stock, you roll back. But otherwise, you can commit the execution. And also, if there was a transaction failure, it would report the error on the commit. Like if, something happened. So normally in Python, you can start and end transactions like this, but anyways, that's the solution. This is technically more advanced, but it's an important idea to understand and to keep in mind. The vast majority of code out there does not use transactions, and it drives me bonkers because, as you can imagine, there's so many failures out there because people don't use transactions. Input validation loop, buffer commits. Yep. And keep this in mind too, which is kind of fascinating. And the reason I called this a session, right? Like, why did I call a transaction a session? Is because you notice this select is querying wallets, right? Looking for the user ID and ultimately getting the balance, right? And the problem is like, if this wasn't in a session, the select, when grabbing wallets, would likely grab the wallet before the subtraction, right? So like if he had a balance of 5 and it subtracts 5, you know, balance could be before or after the query. You see what I mean? So like, it is important to know that if like you do this, this would return the balance before the update, and this would return the balance after the update. You see what I mean? Because that does impact the experience. The order of queries impacts this. And that's why I think of transactions as a session. It's like you're in this little bubble of transactions that are going on, of, you know, queries and stuff. And all of your queries inside of it are impacted by, you know, things that happened during the transaction. So, and let's check it. Does the select from wallets have the balance after the update or before? Pretty confident, but it's fun to validate myself. Because I'm pretty sure it creates a session, and that session has all the, you know, prior updates on that transaction session impacting. Yeah, I mean, you can do junk like this, but after. That's what I wanted to say. To read your writes. A select in the same transaction sees your uncommitted updates. That's the key. Yeah. So what I just said does apply. And yeah, this is getting it more intelligent. But see, this is a lot easier to do inside of Python, right? Like you can keep these queries really dumb and do it in Python. But I just mainly wanted to show you that as a kind of quick educational thing. You won't be quizzed on it. And it really isn't that hard, I think, to like conceptualize and kind of just understand as a, you know, as a feature. But you'll impress somebody like your, you know, teacher or something if you bring it up. You're like, because he'll probably bring it up soon in the class. Like as you know, expand your knowledge, it'll be like a quiz. It'll be like, you know, so how do you fix this situation? Because it's a very common problem. And you can be like, use transaction, you know, simple as that. Anywho, you're welcome. I think when SQL gets hard is you have some like special buzzwords like replace into, right? Because you have usually insert, update, and select, right? These are the bread and butters, right? Create the record, set a value in the record, or get a record, right? This is like 99% of cases. But replace into is, in MongoDB, this is what's called an upsert. And what an upsert means is that it update if not exists, or if exists. Otherwise, insert. You see what I mean? And how it knows to pivot on the replace into is if the primary key, right? Because you usually have a primary key index, if that exists or not. Joining and insertions seem like they're going to be a pain in the ass. Yeah. Replace into is more modern. I think they added it in like 5.6. I guess modern is relative. Like, let's see. When did replace into come to MySQL? And wait, what version? And what year was that version released? My guess is 5.6, and it was probably like 2009, give or take. Joining in insertions seem like they're going to be a pain in the ass. Oh shit. Okay, it's been there a while. 3.21 in 98. Wow. Well, you can tell my knowledge of SQL, you know, while it was 20 years ago, it still doesn't fully remember the history. But SQL's old. Joining and insertion seems like they're going to be a pain in the ass. Insertions aren't too bad. Joining, you know, the key thing with join is if table A, let's say, has column 1, column 2, column 3, and table B has column, let's say, 3, 4, 5, right? There's a couple ways you could do this table join. Like, that would work. You get some weird cases, though. Like, let's say that column 5, for whatever reason, is duplicated. The results of this select are going to be a little wonky because you have an overlap. And you can fix this by doing aliases, where it's like table A, call 5 as... You know what I mean? So, like, you can create aliases to sort of help with those dedupes. There's another way to do selects where it's like this. You see what I mean? You can do like that, I'm pretty sure. There's some weird shortcuts. Inner join is my typical default, but let's say that you want column 5 from table A, you can do a left join. Or if you want column 5 from table B, you do a right join. Like, that concept right there, the joining in left and right and inner. There's also an outer join. I forget exactly what outer join does. I never use it. But anyways, just think of that, right? That's about all you need to know about left, right, and inner and all that shit. Well, left, right, and inner is more about like what table is favored. You see what I mean? Like, think of the direction. There's actually a visualization of it. Yeah, you usually see this crap. So table A, table B. When you do a left join, it's getting the fields from table A, right? Because that's the first entry. So table B fields are ignored. See that? That's all you have to think about. It's not super difficult on that concept. But it includes overlaps, of course. Okay, and then inner join is essentially a merger of the two. And then, of course, right join is all about table B.
It's weird they're doing aliases, but I guess that works. One thing I'm a little curious about, though, is this exclusiveness? Is it because of the null check on the where clause? I don't fully get how it's doing the non-bubble variant. But yeah, full outer join is essentially a full merger, where an inner join is the shared data. And then a full outer join with null check removes the inner. Yeah. Well, think of it more like this, all right? We have two tables, and they're both unique to our wallet. So it's like your wallet, right? This is the first table, and my wallet is the second table. And our wallets are unique. Like mine is, you know, you have a leather wallet, and I have a, whatever those are called, a Ridge wallet, right? And they all have different characteristics, fields, whatever, right? So we have these two tables, and we're going to query them. And so we say, select everything from your wallet, right? Where, you know, color is brown, whatever. So this is just a simple select. You know, this is just going to return all the fields from your wallet. Simple enough, right? Okay, we want to make a table, though, that represents both tables. Or we're going to make a result that has both of our wallets in it. So we have to find some sort of compromise, right? Some sort of thing to merge two tables together, right? We need a pivot. So we got to do a join. I'll usually just do inner joined. This will be my wallet. And in order to pivot, we have to do an on clause, right? So it'll be like your wallet has a field. We're going to, let's just say like ID. That's a classic one, right? Okay. And that ultimately is just like 99% of the time, inner join is what you want. Like I don't even think about it and I just inner join and I almost always have a good result. And that's it. Because like if you wanted to do a left join, you can technically do a left join by just doing this. Right? You're saying, take all the data from my wallet, the fields, and result with those, but use a pivot on, you know, your wallet. So this is a right join. And this is a left join. You see what I mean? And that's an inner join. And then like outer join, you just never use. That's about all you have to remember. That makes sense. Kinda. Yeah. You know, because all tables really are just Excel sheets. And, you know, just like if you were in Google Sheets and you make two, you know, spreadsheets and, you know, they're full of records and you're putting data in there and there's all these different rows of inserts and stuff. If you ever wanted to merge two tables together, right? That's what joining does. You're joining the tables together. And in order to do so, you have to combine on some sort of pivot so that the data can, you know how to combine what records to grab. So, and then how you join is what these terms are doing. Or I guess it's more of like a favoritism on the join, like what leaning you have on the data coming out. So anyways, the truth is in production, you don't actually use either of them that often. Have you tried putting the robot friends in the various study, teaching, homework modes? Those things will go until you're dead or grasp the concept completely. I've never even heard of the robot friends. Are you just talking about GPT? Yeah, I mean, obviously. How does join work in SQL? Inner join only matching rows, left join all left rows, right join all right rows, all rows from both sides. I wouldn't treat it as you're becoming dependent on it. I think it's more about having a conversation with it to understand your knowledge better. Like, I do that all the time. Like, I wouldn't trust like me knowing about gRPC and understanding it was before any of the AI even existed. But I happily will talk to AI for debates. And that's what I'd argue is what's happening here, like what Beef Nips is saying. You're debating it, right? You're trying to expand your fundamentals. So you're just having a conversation. Think of it like, you know, you talk to a student in your class and you're like, hey, I didn't understand the material covered today. Can we talk about it and see if I can better grasp it, right? And that's what you're doing with AI. Ah, what is study mode? I haven't heard of that, Beef Nips. Oh, wait, I'm in thinking mode. I wanted it to be auto. Tools. Where's tools? Look for tools. I like how it typoed the word below. I don't see the word tools anywhere. There it is. Study. I'm learning about joins in SQL. Help me study it. Let's see how this works. Before we start, what's your comfort level? Okay. So yeah, it even gives you like quizzes. Suppose you have users, if you want a list of all orders with the users' names, which join would you choose? An inner join or a left join, and why? If you want a list of orders with the user's names, you would want a left join, assuming users is the first table defined. Yeah. If you had used inner join, users without orders would be dropped. Yes. Suppose you only need the users who have at least one order. Well, of course, it'll be inner join. You literally just said flip it. Imagine you have a table of products and a table of sales. You want a report of all products showing how many times each was sold, even if it's 0. Probably an outer join. Full outer join. That's right. You have to use the full prefix. If we reverse, yeah, see, this is kind of neat. I never used study. Let's change topics to Protobuff and gRPC. I wonder how it'll do with like interviewing on this. Mix in both. Just give me a random thing. Okay, Protobuff is a way to define data structures and serialize them. gRPC is the framework to communicate with it. Yeah. When you design, you don't always want gRPC everywhere. Yeah. Okay, so if you have a combat attack message that's broadcast at 20 Hertz to all nearby players, which transport makes the most sense and why? Quick, because it is I guess also I could have argued about the packet. Suppose you're defining proto files. Would you put your attack intent, attack result in the same file as your gPower service or separate? Separate, because quick on marshals. Well, hello, Chelsea. Thanks for the raid. We're using study mode in ChatGPT, which I've never actually knew about. Beefnips just taught me about it, so I'm having fun studying, I guess you could say. So anyways, yeah, quick, because on marshals the proto message but doesn't implement gRPC, so keeping it separate ensures that the quick implementation doesn't have unnecessary includes and trims bloat. Let's see if I got that right. Hey, Hate Boo, and who's your waifu? Hope you guys are doing well. Did you win in Fortnite? Did you get a winner chicken dinner? Uh-oh. Correct. Keep messages and services split. Why it helps. Quick uses only message proto, while gRPC compiles without dragging quick concerns. Yeah. Don't put HTTP annotations and gRPC options in messages. Reserve, remove field numbers, use one of. Let's actually ask, does gRPC and C++ have a gRPC gateway equivalent proxy for HTTP RESTful endpoint implementation via annotations? Is that emote string an army of advancing cinnamon rolls? That is, I think, yeah. That's hilarious. One complaint I have with ChatGPT is over time, as you ask more and more questions, it starts to like eat up a lot of memory. Like it's not very performant. It'll just start eating up lots and lots of RAM. Like you can see this, it's like lagging. The page is slowing down. Yeah, so there is no gRPC gateway generator. You can use Envoy. Yeah. So what I'd probably end up doing is run a gRPC gateway sidecar and go. Yeah. Yeah, I don't know. It's weird. I'm going to start a new conversation. So just FYI, if you guys use ChatGPT, what you can do is type /study, and that'll add a tag. And now, if you're studying something, AI will not give you answers, but it'll just help you learn about something. I don't know what to talk about though. Let's do RAII and C++ 23. That could be fun. I got this thing sometimes where it's so locked up that I can close the browser window and I'll still hear the audio for the video I've been watching like 15 seconds after the browser closes. Yeah, that's not good. Yeah. Resource is something that must be acquired when later released. Memory, a file, mutex lock, technically object instantiation. You tie the lifetime of the resource to the lifetime of an object. And it's funny it says resource because to me, I think of it as like a stack reservation. So like the lifetime of a function where the acquisition started. The constructor acquires the resource. The destructor releases it automatically when the object goes out of scope. It works reliably. Even if exceptions are thrown, destructors are always run. That's why unique pointer, lockguard, and fstream all exist. They are RAI wrappers. I didn't realize unique pointer was the stewed unique pointer. So I'll start with easy and build up. Okay. Why is RA safer than manually calling open and close in a file in C++? Because you can forget to call close, and if all code paths don't call close, you can have leaks. Exactly. With manual, you'll be responsible for covering every code path. If an exception is thrown and you return early, you might skip close. With RAI, the destructor always runs at scope exit, so the resource is guaranteed to be released. This is making me wonder if it'd be at all beneficial for me to learn some x64 assembly just to get an idea of what's under the hood while I'm working on higher level languages. There's like concepts that are important to learn that are kind of universal. In fact, we'll start a new prompt, and this is stuff that's, I think educational no matter what language you're doing. Help me understand memory allocation and optimization in Python when it's converted to machine code, and, pitfalls to watch out for. This is really all you need to care about, even if you're using Python and stuff. Okay, what memory means in Python? There's objects everywhere. Every value is a pipe object with a header and a payload. Lots of small heap allocations. So ref counting and cyclic GC, immediate increment decrements, a separate cycle collector reclaims containers that reference each other. PyMalloc. CPython small object allocator, arenas, pools, blocks. Fast, but arenas rarely return RAM to the OS, so there's fragmentation risk. There's the GIL side effect. Only one thread runs Python bytecode at a time. Good for allocator simplicity, bad for CPU-bound scaling. When converted to machine code, there are extensions. You write C and C++ that manipulates PyObject. You own borrow references carefully to avoid leaks or crashes. So Cython apparently transpiles to C, adds cdef types to remove Python overhead, and some zero copy buffers and no GIL. Numba, which is a numeric kernel JIT with LLVM, works best on tight loops over NumPy like arrays, avoids Python objects inside the hot path. And then, so these are just different pathways. So object churn in hot loops. So if you have many tiny temporaries, there's GC pressure. These are the things you actually need to care about. Like, essentially, don't instantiate a bunch of temporary things constantly in your main loop because it can cause, a lot of GC pressure, which can cause lag and stuff depending on what you need for performance. Accidental copies. Avoid delete. Use weak ref finalize on context managers. Caches that never clear. Globals, singletons. Try not to hold on to large data. keep scopes tight. Mutable args can have a leak vector. Create fresh inside. Okay. That one is a little weird. I'll clear that one up. Large dictionaries or lists have overhead per object. Use tuples over list if immutable. List growth strategy surprises. Memory not returned to OS when you do annotated resizes. Okay. Anyways, there's a lot of memory considerations in Python. Interesting. Crossing into machine code safety. So when passing arguments for Python, all arguments are mutable by default. And why is this a classic leak vector? That one I think is a decent one to kind of talk about. Default argument expressions in Python are evaluated once when the function is defined, not each time it's called. If the default is a mutable object, every call shares the same object. Okay, so what it's implying is like add item, you pass a array. It's surprising because the argument normally you would almost treat it as if it's in the scope of the definition, but it's actually returning it out of the function and is kind of retaining it. Yeah, they reuse the same items list. That is weird. I didn't know that. That's why it's called a classic leak vector. Ah. Did you know that? I didn't know that. So never put an array inside of your arguments when you define a function. So in my brain, Milfus, typically in most languages, and I got this cough like a dry throat. In most languages, when you work, you'll have some sort of function, right? And you may do like a variable here, right? When this function exits, the typical pattern is this function, all these variable allocations, are added to stack, right? Stack is actually pretty optimized. It's preferred. And I don't know what language this is defaulting to. So the moment this function exits, all these variable allocations get freed, right? Like they are flagged as, you know, either garbage collect ready, or they'll just literally release it, right? So like the lifetime of all these variables are scoped to these brackets. In Golang, if you do something like, you know, if you define a variable called foo in a function, right? When the condition ends, foo is released from stack. See what I mean? So the lifetime of foo is this condition, and the lifetime of any value, you know, we'll make another one here, like, you know, bar would exit here. And in that same respect, if you have, you know, foo bar as a argument here, like this, my brain would assume that everything in this is scoped to just this. So there's not even like a garbage collection pressure for a lot of these variables in here because they're all within the stack. So garbage collection doesn't have to make like deterministic, decisions on like, when do I free this memory? Because it's very straightforward, right? It's all contained inside this function. However, this side effect is that the variable items is staying alive between function calls. So yeah, basically memory in programs go to one of two places. They either go to the stack or to the heap. The stack, if you ever have used a debugger, you have what's called a call stack. And you can think of it like function A calls function B, calls function C, and there's like a breadcrumb, right? And each of these functions is a stack, right? And once the function exits, the stack releases that layer inside of this, like, heavily, stacked upon, hamburger. And in fact, a classic problem is like if you call foo, right, inside of foo, which is called a recursive function, right? Because the function recursively calls itself. So you have like, the snake eating itself kind of problem. This causes what's called a stack overflow, meaning that the whole stack is just infinitely calling itself until it just runs out of whatever the limits are and crashes the program. So, anyways, each of these foos, will be in the call stack, and the lifetime of all of the variables, typically in a lot of languages, are stack based. Stack is cheap, simple to manage, low GC pressure, right? Where the heap is kind of like a reservation pool for memory that ultimately stores variables that are outside of the scope of a function or something like that, right? Because you're allocating new memory for each recursion? No, it's a safety mechanism. The call stack overflow method. That's literally a safety mechanism in all your different programming languages. And that was actually mentioned up here, which is by default, I think everything defaults to... Does Python default to heap or stack for most variables? Yeah, so that's so inefficient. So basically, every variable lives in the heap, meaning that GC pressure is inevitable just by using variables anywhere. Ooh. Isn't this horrible for performance compared to languages that use stacks? Yeah, you get pointer indirection. Every variable is a reference, so even reading an int requires following a pointer to the heap. Oof. Object headers. Each object has metadata, often bigger than the payload itself. So like if you were to define in Python a Boolean, it's really very expensive. You get the allocation free churning, new temporaries, heap allocations, ref updates, possible GC, cache locality lost, heap allocations scatter memory, so CPU caches are underused compared to stack contiguous structs. Yeah, Python is super convenient, is pretty much it. You get the dynamic typing, you have variable size objects, but like as far as being an efficient language, it is the opposite. But yes, it pays a big tax for heap allocation. I like how it typos, but it hides the cost behind the high-level operations and gives you... that's right. It gives you libraries. It's not give your libraries. Yeah. Interesting. I didn't know that about Python. Here's another question. C#, Java, do they use stack by default for short-lived variables and functions? All right, so primitives are stack allocated in Java, and objects are heap allocated. Even if they're locals, local variable slot just holds a reference. So this is kind of a requirement because you don't by default pass pointers in Java, and that abstraction requires the heap. So all your class initializations, arrays, and strings are always heap allocated, and the locals just hold references. So if you pass a string in C# or Java, does it default to being mutable? Or is a copy, a shadow copy created to, and more GC pressure to let you modify the argument string? Pretty much, Milphus. Yeah. So there is no copy on pass. You pass the reference. The callee can't mutate the existing string though. But the moment you modify it, it does create a new string object. String literals are in turn, so repeated identical literals reuse one object. And then you have substring. So let's compare this to Golang. Golang is my go-to. Go defaults to stack, and if you pass string pointers, there's no heap allocation, correct? It'll stay on the stack. String is a small struct. That struct itself lives wherever the variable lives, stack if local. The underlying bytes the string points to are immutable and usually live on a heap. Oh, so there is a heap call for string. By default, locals go on the stack. If the compiler sees the value escapes, you return its address, store it in a heap object, or close over a go routine. Then the compiler moves it to the heap automatically. So just by passing a pointer to X is considered a heap allocation. If you pass a string pointer, whether the data behind the string lives on the heap or stack depends on escape analysis, not the act of passing. Correct. Okay, so it is correct. It's just a little wonky because like strings in Go are abstracted away. And that's pretty good. So sorry, let me go to your question. So your data is just sitting in memory even when it's out of scope. Pretty much. In Java, or sorry, in Python, absolutely. Python has no stack usage really, unless you use some sort of third-party library, is what we just learned. Which means, I don't want to say Python is doomed to fail, but Python inherently has downsides to how it does memory allocation. Like it'll never be properly efficient is basically how you should think of it. Which is interesting. I didn't realize that, like how bad it its discipline with memory is. Well, no, not necessarily. Being in the heap is not a memory leak per se. But it's more like you're almost doomed to have a high memory usage just by using variables in Python, is what it kind of concludes, you know? And honestly, if you're using Python, you're typically writing things that are just sort of, how should I say it, short-lived. They're like scripts or, you know, things that just need to be quickly executed. When you use a framework like Flask, is it heap heavy, where each call is adding GC pressure? Or are they doing like C-struct abstractions in like packages and stuff? But yeah. Interesting. I don't think it's as big of a deal as I'm kind of complaining. It's just in my brain, when I think of performance, you basically just want to avoid the heap as much as possible, right? Because the heap has a cost associated to it, especially when GC has to trigger and manage it. But anyways, that's a tangent. That's interesting. So when it comes to like the assembly part and learning assembly and all that, at least if you're using Python, I wouldn't even touch it. Like, this is the stuff that you really care about, is like, you know, memory allocation, how memory is managed, and all that stuff, which is obviously shown in assembly, but the code is so high level that it just wouldn't make sense if you look at the low level code. You know, like, it's hard to correlate. You need a lower level language like C++ and even like C to compile, and then you can do a comparison in assembly easier. But with high level languages, there's just so much red tape to get the conveniences that you're taking advantage of. It's really more about like disciplines, right? Like, following rules like this is going to be more advantageous to you than understanding, you know, how the code is being translated in the low level, is my argument. And honestly, you don't even need to worry about this. For like the vast majority of projects, you never need to worry about memory until you do, right? Like, let it go. If you get memory leaks, if you get problems, you can run analysis on that. But don't optimize until it's a problem. Just prototype, you know? Kind of what I'm doing. I'm just writing code, moving along, and I don't really even think about so, because I'm still streaming, let's go back to gRPC examples. And we need to see the proto files for this. Also, does buff work with C++, or is that a Go exclusive proto generator? Yeah. Well, and when you think about it, just with what you learned today, with what I was rambling about, doing a bit flag inside of Python is kind of like using tweezers to get dirt from a pile that you're supposed to shovel. You know what I mean? It's kind of pointless. Like, you pretty much are, if you do it in Python and then you're using like bitwise operators might make sense depending on like the data that's coming in, but like doing bit shifting and stuff and bit flags is probably overkill. Okay. I wonder if buff is available in a CMake fetch content call or something. Okay. Yeah, no worries, dude. Thanks for hanging out. I honestly, I should be hopping off too. It's midnight here. I'm just enjoying exploring and talking about code stuff. But honestly, I should be raiding. I'm just lazy. Who should I raid? I don't even know if anyone's online this late at night. I don't know anybody. You guys have a preference? It looks like Broani is on. We can raid him. So, but yeah. No, thanks guys for hanging out. Hopefully you learned something. And I did make progress on decisions. I'm now thinking I should move towards just foregoing support for Nell in my new network service and just start transferring everything over into a simplistic stack that uses gRPC and Quick. Quick for the main pipeline and gRPC for, you know, server to server communication that isn't Hotwire. And hopefully I can do that and keep it pretty simple. We'll see though. But yeah, hope you guys have a good evening. Let me go ahead and hit my ending stream thing, and then I'm going to / raid here. Does it work here? Raid Broani. Yeah, that worked. Anyways, you guys have a good evening, and thanks for watching. Hope you enjoyed Bubble Bobble. And you're welcome. I'm putting every video stream I do in YouTube, so if you ever want to watch them later, I usually take a moment to use the ask prompt in YouTube, so it summarizes it in case you want to highlight reel or whatever. But anyways, not a big deal either way. But yep, have a good one, guys.